Now is introduction. Diabetes is a common disease that affects millions of people around the world. It happens when the body cannot produce enough insulin or use insulin properly, causing high blood sugar level. If diabetes is not detected early, it can lead to a serious health problem such as heart disease, kidney damage, and vision loss. Therefore, this project developed a diabetes detection system using artificial neural network or ANN to help predict the risk of diabetes at an early stage and support better health management. Okay, next is about background. Artificial neural network or N is a machine learning technique that works similarly to the human brain. In this project, a multi-layer perception MLP network and the backpropagation algorithm are used to learn from input data and produce the correct output. The project focuses on understanding how the neural network learn by performing feed-forward calculation, measuring errors, and updating weight through several iteration. This process help improve the network accuracy and demonstrate how neural network can solve classification problems effectively. Okay, now I will explain the problem statement of our project. Diabetes is often diagnosed at the late stage when the symptom become more serious, which can lead to health complication. Traditional diagnosis method also take time because they require medical examination and continuous monitoring. In addition, healthcare data is growing rapidly and can be difficult to analyze manually. Therefore, there is a need for an intelligent prediction system that can analyze data efficiently and help detect diabetes risk at an early stage.
I am Nurulhuda and I will continue with the objective, dataset, and data preprocessing part. In this slide, we have three objectives. The first objective is to develop a diabetes detection system using artificial neural network. The second objective to predict the likelihood of diabetes based on patient health information. The third objective to evaluate the performance of the ANN model in detecting diabetes. Next, we move to the dataset. We use the Prima Indian Diabetes dataset obtained from Kaggle. The dataset contains 768 records and 9 attributes. The target variable is outcome, which is used to determine whether a patient has diabetes or not. Next, we move to the data pre-processing. This flow shows the pre-processing step performed before the dataset is used by the artificial neural network model. The process starts with the raw dataset, followed by missing value checking, detecting invalid value, data cleaning, standardization, train test split, and finally producing a clean dataset.
Detecting invalid value. At this stage, we check the database for invalid value. Although there were no missing values, several attributes contain unrealistic zero values. Those values were identified as invalid because they could affect the accuracy of ANN model. Data cleaning. To clean the data, the invalid zero values were replaced with NAN and filled using Median imputations. These help improve the quality and reliability of the dataset before training the model. Standardizations. Next, we apply standard scale to standardize the dataset. These ensure all features are on a similar scale, helping the ANN model learn more efficiently. The dataset was split into 80% training data and 20% testing data.
Artificial
artificial neural network or ANN architecture used in this project. The input layer receives 8 health-related features from the diabetes dataset, including glucose level, blood pressure, BMI, insulin level, age, and other medical attributes. The first hidden layer contains 16 neurons with ReLU activation to learn important patterns from the dataset. The second hidden layer contains 8 neurons which further process the extracted information. Finally, the output layer consists of one neuron with a sigmoid activation function that predicts the probability of diabetes risk, either low risk or high risk. This slide shows the learning process of the ANN model. First, the diabetes dataset is collected and pre-processed to ensure the data is clean and suitable for training. Next, the dataset is divided into training and testing sets. The ANN model is then built and trained using the training data. During training, the model adjusts its weights to learn patterns from the dataset. After training is completed, the model is evaluated and used to generate prediction results for diabetes risk. This slide illustrates the workflow of the proposed system. First, the user enters health information through the input form. The system then validates the input data before sending it to the backend. The ANN model processes the information and calculates the diabetes risk probability. Based on the prediction results, the system will display either a low risk or high risk outcome. Finally, the result is presented to the user together with relevant health recommendations.
I'm Elsa Yasmin, and I will be presenting for results and findings. The project was successfully completed and the ANN model was integrated with the web-based system. The system is able to classify users into high-risk and low-risk categories and display the prediction results through a user-friendly interface. This demonstrates the effectiveness of ANN in supporting diabetes risk prediction. For the demonstration, the user enters health information such as number of pregnancy, glucose level, blood pressure, BMI, and age. After clicking the Predict button, the data is sent to the ANN model for analysis. The model calculates the risk probability and displays the prediction result. In this example, the system predicts a high risk of diabetes with a probability of 81.65%. In conclusion, our project successfully developed a diabetes detection system using artificial neural network technology. The system can analyze patient health information and classify users into either high-risk or low-risk categories. The ANN model was successfully integrated with a web-based interface, allowing users to obtain prediction results easily. Overall, this project demonstrates how deep learning can be applied in healthcare to support early diabetes detection and decision-making. That's all from our group, Group E. Thank you.